go. All right, so solving equations involving absolute values. The last new stuff in this unit. When dealing with absolute value equations, there are 3 steps. Step 1, isolate the absolute value expression on one side of the equation. Step 2, split the equation into 2 cases and solve for each case. Step 3, verify/check your solutions, or roots, as they may be extraneous. Right? So it might be a solution to the equation that you've set up, but not to the original. So let's look at an easy equation to solve involving absolute value. Solve for the absolute value of x equals 9. Now, since we know the absolute value of 9 equals 9, and the absolute value of negative 9 is equal to 9, this means that x could be plus or minus 9. Right? So we have 2 cases, right? Positive value and negative value. Mathematically, definition of absolute value of a is just a. If a is greater than or equal to 0, right? So if a is positive, you return a. If a is negative, so if a is less than 0, it's negative, you take the negative of a negative, that's going to turn it positive. So we negate it. Or for this equation, absolute value of x is x. If x is greater than or equal to 0, that's case 1. And case 2 is that it's negative x if x is less than 0. All right, now let's see if I can move the page without moving the border. All right, so absolute value of x equals 9, case 1. Absolute value of x equals 9. If x is greater than or equal to 0, if it's positive, then we know that x is equal to 9. Case 2, if x is less than 0, then we know that negative x is equal to 9, right? We take the negative of x. Piecewise function, right? Case 1, this part. Case 2, this part. What we do, we split it into a piecewise function. And in that case, then x is equal to negative 9. You check this solution is valid because it's greater than or equal to 0. See, we said x has to be greater than or equal to 0, and it is. And here, we said x has to be less than 0, and it is. Okay? So that's one way to check, to make sure that what we said is actually true. All right. Page 2. Something a little more complex. Solve the absolute value of 2x minus 5 is equal to 9. So, we have to split this into our cases. In order to do that, we got to think about, okay, well, what's the absolute value of 2x minus 5 looks like? So 2x minus 5, y equals 2x minus 5 is a straight line. Slope of 2, y-intercept of negative 5, right? Absolute value of 2x minus 5, we know, will be a straight line, but it's going to v, right, at some point. When the values of this go negative, then we turn them positive. So what we first need to do is figure out where is 2x minus 5 equal to 0, which means 2x is equal to 5, or x is equal to 5/2. Okay, any number bigger than 5/2 is going to make this positive, right? So 2x minus 5 will in fact be 2x minus 5 if x is greater than or equal to 5/2. All right, and we always throw the 0 in with the upper, okay, with the positive part. If x is less than 5/2, then we have to take its negative. Okay, so here, let's go look at this. We look at a picture. Y equals 2x minus 5. Okay, so there's the graph, 2x minus 5. There's the 5/2, right, also known as 2.5, right? Let's do absolute value. Y equals, I think I can get away with ABS. And I can. Right, so here's our deal, right? If x is greater than 5/2, right, that's our red line, then that portion of the graph was positive anyways, right, or is positive. So we don't make any changes. We just use 2x minus 5, which is the red line. However, below 2.5 or 5/2, these values are negative. So we have to take the negative of them to turn it positive and get this. Right? And then so the blue graph here is the absolute value graph. Okay, so that's why we solve it for where it's 0, right? We can draw a little sketch of it if we like. So, maybe a little sketch wouldn't hurt. So 2x minus 5, it's got a y-intercept of -5 and a slope of 2, right? So we're looking for this point, which is 5 over 2. And based on our sketch, we know that to the right of 5 over 2, it's positive. So we're just going to leave the function as it is. It's going to return a positive value. To the left of 5 over 2, the original function is negative, right? Y equals, this is y equals 2x minus 5. Okay? And then what we want to do is get the absolute value, which is this guy here. Okay, so we have two cases. Case number 1, 2x minus 5 is equal to 9 if, case 1, if x is greater than or equal to 5/2. So what we're going to do is we're going to solve. So go ahead, solve. 2x minus 5 is equal to 9. Solve for x. Take a couple of steps, show your work. It doesn't hurt. We all know it's 7. Right? But take a couple of steps, show your work. Right? Because what you do on an easy linear is what you're going to do on a much harder quadratic. And if you're just kind of looking at it and solving it by inspection, that's not going to work as well on a quadratic. All right, so we're saying that x is equal to 7. Case 2, it's the negative of 2x minus 5 is equal to 9. All right, so we're going to solve this. So we will distribute the negative through here, go negative 2x plus 5. Oh, wait, if x is less than 5/2. So we're going to distribute the negative. Negative 2x plus 5 is equal to 9. Negative 2x is equal to 4. X is equal to negative 2. So, looking at the solutions. This says x has to be greater than or equal to 5/2, and it is. This says x has to be less than 5/2, and it is. So then those solutions should work. What's another way you can check your solutions algebraically? So first off, let's state the solution set. Okay, so x is equal to negative 2 or 7, right? That's in brace brackets, not in parentheses. If you put it in parentheses, it becomes a point. We don't want a point. There's not a point here. Right? It's just two values of x for which this is true. How can we verify this? Grab this. So to check your solution algebraically, I like to do a left side, right side. So I'm going to say the left side is equal to the absolute value of 2x minus 5. We're back in the original equation, right? Because that's what we're checking, is does this solve the original equation? We're going to try, so here we're going to verify if x is equal to 7. That's the first one. So the left side is the absolute value of 2 times 7 minus 5, which is the absolute value of 14 minus 5, which is the absolute value of 9, which is 9. Okay, it's equal to the right side. We don't have to manipulate the right-hand side at all, because the right-hand side has no variables, right? It's just equal to 9. Similar check, if x is equal to negative 2. Okay, I don't need much space on the right-hand side, right? Because it's just equal to 9. So you can't cross sides. Don't treat it as an equation. When you're verifying, don't treat it as an equation. Oh, I'll add 5 to both sides, or I'll do this or that, right? You can only work one side. So the left side is the absolute value of 2x minus 5. We're going to substitute in. So 2 times negative 2 minus 5 is negative 4 minus 5, which is the absolute value of negative 9, which is 9, and that verifies. Okay, any questions on that one? So far, so good. So what we've got to do is we have to take the absolute value. So the method was what? Isolate the absolute value on one side. Figure out the cases. Okay, so we have to go through and say where is, we're just going to use the original function as it stands if it's going to yield a positive result. And we take the negative of the function if it's going to yield a negative result. There we go, right? So we have to state the piecewise function here and then solve two cases. All right, let's kick it up a notch. Oh, all right. Solve graphically. So I've kind of got the graph here, right? I mean, we could make it equal to 9. Right, so that would be here. Where are we? Negative 2, 9. You can see it. And here, I want this to be equal to 9. There's 7, 9. Okay. Now, I mean, that's not what they really mean. So let's go on to our calculator. Okay, I'm just going to reset it. Second mem 7, left arrow, enter 2. Be looking for resetting instructions. It appears 11 minutes and 20 seconds of the video. Y equals. Okay, absolute value. It's under the math menu. Over to num. There's ABS. Okay, so we want 2x minus 5. 2x minus 5. And we want that to be equal to 9. Okay, I'm going to go, oh, I don't really have to, zoom standard. So standard window, it should fit in the standard window. You know, it's not the greatest. We could kind of come in on this region, but it's enough for us to be able to see, right? We can see it. So go second, calc, intersect. Move to about the point of intersection. 1, 2, 3. Negative 2. Second, calc, intersect. Move. Now I don't want to move down the blue line, so I'm going to jump up to the red line here so that I can get there faster. It's pretty slow on this anyways. And 1, 2, 3, and 7. Okay, so there's a graphical verification. Solve graphic. Oh, one other way. What else could we do? You could do the absolute value of 2x minus 5 minus 9 is equal to 0. Right? So you can do this. y1 is equal to the absolute value of 2x minus 5. y2 is equal to 9. The x window is negative 10 to 10 by 1s. The y window is negative 10 to 10 by 1s. Okay, we've got our thing. We're going to do an intersect. Okay, so use intersect to get the x coordinate. Well, let's just say x value. Okay, so second calc intersect. We got a negative 2. We got a 7, right? So that's y1, y2 intersect. Or y1 is the absolute value of 2x minus 5 minus 9. So let's go here. Y equals absolute value of 2x minus 9. Okay, and y2, I can put a 0 if I like, because especially on this calculator, right, it's short as a nice red line. And instead of doing a second calc 0, I do a second calc intersection, right? And we'll just do 1. And you can see that it's going to be negative 2. 1, 2, 3. And if we verify the other one, it would be 7. Right? So it's two ways to verify. Or y1 is equal to this. X, still negative 10 to 10 by 1. Negative 10 to 10 by 1. Okay, sketch it out. Oops. Sketch it out, what it look like. Okay, and then you're getting the zeros. Find the zeros. Okay, so any questions about a graphical verification? Right, so algebraically, plug it in, work the left side and the right side separately. So absolute value 2x minus 5 equals negative 9. All right, what's this going to work out to? Why is there no solution? The absolute value has to be positive, right? So since the absolute value of there is no solution. Okay, so you can write it out like that. Just say the left-hand side is an absolute value. Therefore, the left-hand side of this equation is greater than or equal to 0. So it can't be equal to negative 9. There is no solution. Okay? If you tried to solve it, you could do the two cases, right? Because you can actually find values. If you said, well, when is 2x minus 5 equal to negative 9? You know, then 2x is negative 4. Yeah, but here we'd be saying if x is greater than or equal to 5 halves, so x is negative 2. So in case 1, we would say just use the normal, right? 2x minus 5 if x is greater than or equal to 5 halves. But if we solve this, we now have a problem, right? The solution we get is x is equal to negative 2. But the case we're solving says that x has to be greater than or equal to 5 halves. So problem, right? So this is not a solution. So here, case 1, right? So not a solution. Similarly, case 2 would be the negative of 2x minus 5. 2x minus 5 equals negative 9 if x is less than 5 halves. So here we go, negative 2x plus 5 is equal to negative 9. Negative 2x equals negative 14. X is equal to 7. Right? But 7 is not less than 5 halves, right? So it violates the case. So no solution. Okay, so when we solve the cases, we have to get values that are consistent with the case. Right? And those cases just go back to the original, right? Case 1. Absolute value of 2x minus 5 is 2x minus 5 if x is greater than or equal to 5 halves. Yeah.
Is it possible to have like one case works and the other one doesn't?
I don't know. Let's find out. So you must always check your solutions with absolute value equations because there may be extraneous roots. Okay, in this case it was extraneous roots, right? Like we tried solving it, but it went against the cases. So an extraneous root is a root that's introduced into an equation in the process of solving, but it's not a solution of the original equation, right? So I mean, we looked at the original equation and said, that one just can't be solved, right? But what if we did try solving it, right? What if it's something we didn't recognize that, oh, this is a case that can't be solved, right? So when we go and solve it, then we have this thing where I have an answer, right? Because you can solve 2x minus 5 equals negative 9. I have an answer, but it violates the case. All right, a little more difficult. Solve the following equations algebraically. The absolute value of x minus 2 is equal to 3x plus 1. Okay, so first thing you got to do, you think about what is x minus 2. So y equals x minus 2 would be a line like this. That's y equals x minus 2. Here's the absolute value of, what we're interested in at this point here, right? So when is x minus 2 equal to 0? When x is equal to 2. So if x is greater than 2, we know that x minus 2 will be positive, right? So that's our first case. So what we do is we now define the piecewise function. Okay? It's got nothing to do. 3x plus 1 is that's not in our wheelhouse right now, right? We're not looking at the 3x plus 1. We're simply looking at the x minus 2. Think about what does it look like? It's a straight line. It's positive when x is greater than 2, greater than or equal to 2. So that's equal to, okay, 2 cases. So it just is what it is if x is greater than or equal to 2. Otherwise, it's the negative. Otherwise, it's negative bracket x minus 2. Okay. Otherwise, it's the negative of x minus 2 if x is less than 2. Okay. So we have the original step 1 was isolate the absolute value. It is isolated, right? So we don't have to do anything. It's isolated. Look at the cases, split it up into a piecewise function. Okay. Did you say that again? Yeah, split the equation into 2 cases and solve for each case. Okay, so we're going to go with case 1. X minus 2. Oh, let's call it case 1. Case 1. X minus 2 is equal to 3x plus 1 if x is greater than or equal to 2. Okay, go ahead, solve. Okay, solve for x. This can be solved for x, right? There is an answer. The question is it a valid answer? All right, so is it valid? What do we end up with here? Negative 2x is equal to 3. So x is negative 3 halves. Okay, if it's not valid, what's wrong with it? Yeah, it should be greater than or equal to 2, right? We need an x value that's greater than or equal to 2. This is not greater than or equal to 2. It is less than 2, right? So we are going to say it's extraneous. All right, let's try case 2. So case 2 is the negative of x minus 2 is equal to 3x plus 1 if x is less than 2. Okay, that's case 2. Solve case 2. However you like. Well, algebraically. Okay, is case 2 okay?
Yes.
So is 1/4 less than 2? Yeah. So this one should be okay. Should be okay, right? So we're going to say x equals 1/4. Okay, that's our solution. Now, let's just show again, what if we forget about this? What if we forget that x has to be greater than or equal to 2? We just sort of write case 1 down, we solve. How do we know? So we can do a left side, right side thing again. So the left side is the absolute value of x minus 2. The right side is 3x plus 1. So in this case, we have x's on both sides, right? So again, we don't violate this line, right? We work on the left-hand side. Nothing can move. You can't move as, oh, let's subtract 1 from both. No. There are no both sides, right? There's a left side. So the absolute value of negative 3/2 minus, okay? So I'm going to call 2 4/2, right? Because 2 is 4/2. So this gives me the absolute value of negative 7/2, which is equal to 7/2. And now I want to see if the right-hand side will be equal to 7/2. So that's equal to 3 times negative 3/2 plus 1. So that's negative 9/2 plus, and I'm going to change the 1 into 2/2, which is negative 7/2. Okay, are these guys the same? Nope. Got a positive on one side, negative on the other. That's what's going to happen in absolute value, right? You get a positive on one side, but you get, like, the absolute value side will always be positive. So if the other side evaluates to a negative, you, oops, nope, that's not the case, right? So that's a double check on this thing here, right? By saying this, but this is an algebraic check. And similarly, we'll do the x equals 1/4. So the left side is equal to the absolute value of x minus 2. The right side is equal to 3x plus 1. All right, let's do the right side first. 3 times 1/4 plus 1 is 3/4 plus 4/4 is 7/4, right? That's just changing 1 into 4/4, so we can add, right? So they're fractions. Here, got 1/4 minus 8/4. Okay, just changing the 2 into quarters, it'll be 8/4, right? 8/4. That gives me negative 7/4. Well, the absolute value of negative 7/4, which is 7/4. Left side and right side are the same. You have a verification. Okay, nice algebraic verification. You can also verify graphically. So if it's multiple choice, you don't really have to show any particular verification, right? You could just graph it and say, yeah, okay, there's only one solution, right? That's all I see in here is the 1/4. I don't see a solution at negative 3/2. Okay, if I try graphing. Any questions? Let's kick it up a notch. The absolute value of x squared minus 2x minus 8 plus 3 is equal to 2x. What's your first step? Based on step 1, isolate the absolute value expression on one side of the equation. Which means we got to do what? Okay, so we got to move the 3, right? 3 just gets subtracted. If you add 3, it's not going to be fun to mark, right? Because it's just all going to be wrong. Okay, where do we start? Well, we have to know what the absolute value of x squared minus 2x minus 8 looks like. So, it's a quadratic. Which way does it open? Up. Where are its zeros? So we're going to go over here. X squared minus 2x minus 8 is equal to 0. Going to factor it. Two numbers multiplied 8 differ by 2. Okay, we should be able to find those. 4 and 2. So what is it? X plus 4, x minus 4. So I got the 4 and the 2. Plus 4 minus 2. Okay, that's wrong.
That's wrong.
Yeah. Because what does that give me? X squared minus 2x plus 4x will be a plus 2x. Okay, so that's the plus. That's the minus, right? If you go wrong at that step, it's like the whole thing becomes a mess. Like literally, because when you go to solve, things that should happen don't happen anymore, right? They're just numbers. It won't make any sense. You'll be pounding away at it for 10 or 15 minutes trying to make it make sense, and it won't, right? Because it's wrong. All right, what does that look like? So where are the roots? Okay, what's x? X is equal to -2, +4. Okay, what's this thing look like? Well, it's a quadratic. It's got a root at -2 and +4. So it looks like this. Okay. That analysis, right? The one that was on in the previous unit. This is that exact analysis of just where is x squared minus 2x minus 8 greater than 0, right? This is what we need now. Okay, so that question on the test, that section of the work, was all leading to this. Okay, it's just a tool that gets used now. It's not even an end in itself. It's not like, hey, answer this question. It's like, you need to do that in order to work this question. Because what comes next? Well, we say, what do we say? We say the absolute value of x squared minus 2x minus 8 is equal to, okay, so it just is what it is, right? It's just x squared minus 2x minus 8. Under what conditions? Yeah, so we're going to put less than or equal to. So less than or equal to -2, or x is greater than or equal to 4. All right? So we have to do the analysis on that quadratic, right? Which we can do graphically. It's fine to do graphical, right? You don't need to sit and do a sign analysis, case analysis, or anything like that. You have to say, hey, when I have x squared minus 2x minus 8, where is it positive? All right, how do I figure that out? Well, let's get the zeros. Because if there's a 0, then the function is going from positive to negative or negative to positive, right? If you're passing through 0, you're coming down and going through 0, you're going up. So here, we're coming down through 0, and then we're going up. When is the function negative? So just say between -2 and 4, the original function is negative, right? Okay, here, let's get a picture of this. X squared minus 2x minus 8. Y equals x squared minus 2x minus 8. Okay, so there's... Okay, there's the graph of x squared minus 2x minus 8, right? There's the -2, there's the 4, it's positive up here and here, it's negative down here. We want, what did we want this to be equal to? We want this to be equal to 2x minus 3. Let's go back here. So what if we do y equals 2x minus 3? All right. This is earlier in the unit, this is what we would have solved, right? We would have solved x squared minus 2x minus 8 equals 2x minus 3. Before we did absolute value. This is just solving a system, right? It's a quadratic linear system. The answer to this would be 2 points. This point here, which is garbage. This point here, which is -1, -5. And another point up here, okay, which is like 5, 7. Okay, but that's not what we're solving, right? What are we solving now? We are doing y equals the absolute value of x squared minus 2x, x squared minus 2x minus 8. Okay. So we're not interested in this point here, right? We're not interested in anything that's going on down here. We're interested in what's happening here. Now we can see we've got 2 solutions, right? Okay, so that's graphically. So going into this, we know there's 2 answers. And we could kind of figure out what they are, but we will. We're just going to do it algebraically. Okay, so we're not interested in the green, right? We're interested in this. Okay, it's not a system as such, right? So we're just finding the x values. What are the values of x that make this equation true? All right, so case 1. So case 1 is x squared minus 2x minus 8. This guy here is equal to 2x minus 3. Okay, so case 1 is the where it's positive. Okay, what's the proviso on case 1? So it's if x is less than or equal to negative 2 or x is greater than or equal to 4. That's going to help us, right? When we solve this, we know, hey, if I get a number that's below negative 2 or below, or I get a number that's 4 or above, that's a good solution. Okay, solve. Solve that equation. There's your first step. Right? How do I solve a quadratic? Set it equal to 0. Then what? Try factoring it. Right? If it factors, huzzah, life is good. If it doesn't factor, it's a quadratic formula. Life is still good, but it's a little bit of work going on there. Okay, factor. So what do we got? Smart, zip, 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 zip. It's like all new stuff. Okay. It's like everything we've learned all year is coming in on this stuff. Quadratic functions, quadratic equations, factoring to solve, analyzing a quadratic for where it's greater than or equal to 0, where it's less than 0. Okay, what's good, what's bad? X equals 5. Thumbs up, thumbs down.
Thumbs up.
Thumbs up. X equals negative 1.
Thumbs down.
Thumbs down. You shall live, and you shall not. Okay? Based on the cases, this case said, if x is greater than or equal to 4, okay, 5 is bigger than 4, or x is less than or equal to negative 2, but negative 1 is not, okay, so we cross off the negative 1. Okay, case 2. Okay, squeeze this in here. So case 2 is the negative, right? This is case 2, right here. So we write down, oops, negative x squared minus 2x minus 8 is equal to 2x minus 3. So the right-hand side never changes, right? It's just the absolute value side. If, so it doesn't hurt to put this on here, right? If negative 2 less than x less than 4. So as long as x is between negative 2 and 4, we're good. Okay, solve. You can probably expect one like this on the test. So I'd leave it for later, right? It's not, it's not impossible or anything like that, right? It's just a lot of work. Okay. And you got to make sure that at every kind of intermediate step up here, your work is correct. Okay. If you rearrange wrong, if you factor incorrectly and don't catch it, right? All of a sudden, here's the problem, right? Instead of ending up with, hey, this factors quite nicely, here's some nice little numbers, you start ending up with, I'm using the quadratic formula and I get, negative 5 plus or minus the root of 17 over 12 or something. Or worse yet, I get negative 5 plus or minus the root of negative 17. It's like, now this has no solution. But I graphed the thing. I know that there's a solution somewhere. Why is this showing, right? Becomes a big problem. All right, what are we going to do? Blip. Oh, that's nice. Yeah, but okay, so hey, the x's went away. We got a nice little simple part, just like negative x squared plus 11 equals 0. Well, how do I factor that? You don't. You isolate the square. All right, so wait, but I want it to be a positive, so I'm going to multiply through by a negative. So now it's x squared minus 11 equals 0. Now it's x squared equals 11, which means that x is plus or minus root 11. Okay, what's root 11? It's like between 3 and 4, right? Okay, root 9 is 3, root 16 is 4, root 11 is between 3 and 4. Okay, so is positive between 3 and 4 in here? Yeah. Is negative between 3 and 4 in here?
No.
Right, no. So that's, the negative root 11 is somewhere out here. Right? It's somewhere over here. The positive root 11 is. So let's write them both out separately, and then let's cross out the one that's no good. Okay, so we have a solution, right? X is equal to root 11 and 5 in brace brackets. How's that match up with this graph? What's the square root of 11? It's not 3.317?
Yeah, that's right.
Okay. What's 5? Garbage. It's garbage. Boy. Come on. 5. Okay. So the solutions are 5 and root 11. And we can see the solutions here, right? So graphically we verified this, right? Algebraically, we have to verify algebraically. Now, did it say to by any chance? Any instructions? Got to go back. Look at the general. So we're going to our solution. Solve the following equations algebraically. Well, you know what? It's not going to kill us too badly. So x squared minus 2x minus 8 plus 3. Extend the page. So the left side. And the right side is, okay, I'm just going to look on the sheet, 2x. 2x. Okay, if x equals 5. So the left side is, wow, how'd that happen? Oops. Okay, so left side is 5 squared, the absolute value of 5 squared, minus 2 times 5, minus 8, plus 3. So 25 minus 10 minus 8. So 25 minus 18 is 7. And 7 plus 3 is 10. And this is 2 times 5, which is 10. So that checks. Okay. Worked out nicely. Yay. Root 11. X squared minus 2x minus 8 plus 3. Right side is 2x, which will be 2 root 11. So we are rooting for 2 root 11 over here. So root 11 quantity squared minus 2 root 11 minus 8 plus 3. Okay, so the root of 11 squared is 11. So we got 11 minus 2 root 11 minus 8 plus 3. So we have 3 minus 2 root 11 plus 3. So what's the absolute value of 3 minus 2 root 11? Yeah, so like algebraically, this one is not, right? This is where you just sort of go, and I verified this one graphically, right? I found out that it's, can we do that? Well, I mean, so we can work out a value, right, on our calculator. So what do we have? 3 minus 2 root 11? 3 minus 2 root 11. Okay, so then we're going to turn that positive. Oops. Okay, so that's 3.632 6 point whatever 63, and 2 root 11 is 2 root 11. Right. So if you add 3 to this, you're going to get this. Check. Okay. Now, in a sense, we verified it above, right? Because we said, based on our cases, root 11 works, negative root 11 doesn't work. Okay? I don't know that we ask you to do a verification of this particular. Okay? But at some point, you need to be checking answers. Okay, one more. X squared plus x plus 9, the absolute value thereof is equal to 3. So, what's x squared plus x minus 9 look like? Does it factor? The answer is no. Because the only thing that's going to give us a 9 is a 1 and a 9, which you cannot combine to get a 1, or a 3 and a 3, which you cannot combine to get a 1. Okay, so if we graph this, y equals, clear, okay, so that, clear. Okay, what is x squared? X squared plus x minus 9 look like? Okay, so it's got a root that's like 1, 2, 3, a little bit below negative 3 and between 2 and 3. Okay, but something like that. So our cases are going to be this, right? We can't actually put a value to these guys without going to a lot of work, right? We would have to use quadratic formula to solve. It's not worth it. So we're just going to say, okay, look, it's case 1. Okay, now we know, looking at the diagram, we know if it's bigger than this number, which is somewhere between 2 or 3, or smaller than this number, that's what matches that case, right? This is, where is this thing positive? Okay, we're going to say, we don't know, but we know that at some point it's positive. And it's going to be the negative of this, right, if x is between. Okay? So this is going to give us an idea, but we'll have to verify algebraically then, right? Because we don't have any way of verifying this from the cases. Okay, so let's set it up. And let's hope for the best. So case 1. X squared plus x minus 9 is equal to 3. Which gives us x squared plus x. Then what? Minus 12. That's nice, that factors, right? X squared plus x minus 12 equals 0. Okay, good. Factors. It's got a plus, it's got a minus, it's got a 4, it's got a 3. Okay, so x is negative 4 or it's positive 3. Now, negative 4 seems to fit, right? Look at the graph. This is case 1. Case 1 is where it's positive. Based on the graph, negative 4 is going to work. So is 3, right? Both of these guys, based on the graph, and just rough sketch, say, hey, both of these guys are going to work. Okay, so based on the graph, based on graph, these are solutions. Case 2 is the negative of x squared plus x minus 9 is equal to 3. So negative x squared minus x plus 9 is equal to 3. Negative x squared minus x plus 6 is equal to 0. X squared plus x minus 6 is equal to 0. X plus 3, x minus 2 is equal to 0. X is equal to negative 3, or x is equal to 2. For case 2, those are going to work. Looks like, right? Because at negative 3, we know that the graph is negative. And at positive 2, we know that the graph is negative. And case 2 is where we're looking here. We want these to be negative. Okay, we want it to be below. So remember what the absolute value is going to look like is this. So at negative 3, we're going to get a solution, right? Because we want this to be equal to 3. That's here. There's 3. There's our graph, right? Well, draw it in red. Here's our graph. So it looks like we have 4 solutions, right? And the way we're going to do this, we'll verify it graphically. So we're going to graph y equals, okay, so here, x squared, we're going to do the absolute value of this. Right, just insert an absolute value. Math. Yeah, I can, but it's not going to work. Okay, so we got x squared plus x minus 9. And down here we got a 3. Window, we'll leave negative 10 to 10. We don't really care about what's happening down here, so we can go 0 to 10. Because we know that our graph has to be above, right? And then here's your solution at 3. So we have 1, 2, 3. We have the 4 solutions, right, that we have found. So graphically, we have verified. Okay, so let's just say based on the graph, based on the above, algebraic work, and a graphical verification, the solution is x equals let's go in order, negative 4, negative 3, 2, and 3. Okay, and you can see those on the graph there, right? If you look scale-wise, you get 1, 2, 3, 4, negative 4, negative 3, 2, 3. Okay. All right, so we could draw the graph, get an idea, right? So as we were solving, we had this idea. Negative 4 is going to work, 3 is going to work. As we were solving, we had the idea, I think negative 3 and 2 are both going to work. Okay, but what we want to do is run a graphical verification. So we could just sketch out the graph, basically. And show this, okay, based on the graph. So here's the graph. Based on that, we have 4 solutions, and they are blah, 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 blah. Pause. Okay, and then each of these values could be verified in here, right? So the left side is equal to x squared plus x minus 9, absolute value. Right side is equal to 3. So if you did x equals 4, you'd get 4 squared minus, or sorry, negative 4. You get negative 4 squared minus negative 4 minus 9. Right, sorry, plus, yeah, x squared minus 4 minus 9, which would be 16 minus 13, which is 3. Okay, so it works for negative 4. Then if you did negative 3, okay, we'll just sketch through. So negative 3 squared is 9, minus 3 is, okay, you got 9 minus 9 is 0, and then you've got the negative 3. So with the negative 3, this will work out to negative 3, absolute value of which is 3. With the 3, it's 9 plus 3 minus 9, which will give you 3. And with the 2, it's going to be 4 plus 2, which is 6 minus 9, which is negative 3, but absolute value, so it's positive 3. So all of those would work algebraically, would be fairly easy verification.